So welcome here, and as you all know, in some parts free software is very dominant and the choice of if you want to do something. There are some parts where free software is not yet as successful as it wants to be, but there are projects trying to change that. And one of these projects is Libreboot, and I think we can very happy to have the founder of this project, Lear, here now on stage talking about it. Thank you very much. Give a warm welcome.
Okay, so as we've introduced, my name is Leo Rowe. I'm here to talk about a project called Libreboot. I've been working on this project since late 2013. What Libreboot attempts to do is provides free software at the boot firmware level. So when people think about free software, they're usually thinking about their operating system. But the boot firmware is basically what initializes the hardware and starts usually a bootloader to load your operating system. So most people with modern systems are using proprietary software. So this is often referred to as the BIOS or UEFI. Libreboot attempts to provide a fully free software replacement for this. So we provide this on desktops, laptops and servers on x86 and ARM. We're also looking to implement this on OpenPower, which I'll talk about later in the talk. So the goal of the project, we want everyone to use free software exclusively. So we think proprietary software shouldn't be an option. If anyone's using non-free software, then that's a problem. We want to fix that. As a result of this, our second goal is obviously to support as much hardware as possible. So the more hardware supported, the better. This includes not just porting existing hardware to Libreboot, it also includes having OEMs provide Libreboot pre-installed. And we also want it to be as easy to use as possible for non-technical people. With projects like this, it's usually the case that people who may not necessarily have the technical knowledge might not even know how to install it, either because there's no documentation or because the documentation is incomplete, or it may use jargon that the user doesn't necessarily understand. So we want to streamline everything in Libreboot as much as possible. And this will be covered later on in the talk. So what are the problems with non-free BIOS or UEFI or boot firmware more generally? So if you're familiar with what free software is, basically it means you can use the software, copy it, share it, modify it, study the source codes, basically do whatever you like with it with no restrictions. If that's non-free at the BIOS level, then we see now, for instance, that you have devices where the operating system that the device comes with is locked down so that you can't replace it. This is most common on games consoles and mobile devices, but it's also increasingly common nowadays on PCs as well. I'll go on to this later on in the talk. You also find nowadays, I'll also cover this later on in the talk, that some modern boot firmware also is cryptographically signed, which means you can't replace it. So on some modern Intel systems, you find that you can't replace the boot firmware because the system checks the signature at boot time. I'll also cover this later on in the talk. Obviously, with proprietary boot firmware, you can also have security issues, intentional or otherwise, which can be placed there by the manufacturer. So, for instance, system management modes, you can implement rootkits there. Most modern Intel and AMD systems also come with a hypervisor called the Intel Management Engine, or the AMD Platform Security Processor. I'll also cover these later on in the talk. If there are bugs, obviously all software has bugs. That's a problem if the software is proprietary and no one has the source code to actually learn how it works and make changes to it. So, and it's common to find issues with boot firmware on modern systems or any system. We want people to be able to fix issues that they may have. With proprietary software, this is not the case. So that's important. What's the point in using a system that's non-free? If you're going to use a free system and want to use all free software, but the boot firmware, the root of trust in your system is proprietary, then that's something that needs to be fixed. So I'll go through some brief history of the Libreboot project. It started in December 2013. I was running a company at the time called Glug. It's now called Minifree. I was selling the ThinkPad X60 with Coreboot pre-installed. The Free Software Foundation contacted me to tell me about their Respect Your Freedom certification program. What this was, or is rather, is a program where they certify devices that come exclusively with free software, but not just that. Also, devices that contain no known security issues, so no backdoors or anything like that. These systems at the time were the first systems that actually met this criteria. Everything, including the boot firmware, the operating system, the drivers, any software that you can think of in the system was free software, and this is what we worked with them on. The Libreboot projects hadn't started at around this time when they contacted us. We had to work on some issues. So the Coreboot contains, I'll go into some details about the problems that we had in Coreboot, because that kind of goes hand in hand with this. So yeah, so they contacted me because they wanted to endorse my company. So I started working with them on producing a completely blob-free version of Coreboot. A blob, by the way, is a piece of proprietary software, binary-only software. I worked with them on creating a product that was entirely free software, and from that, the Libreboot project was formed. We also only supported one laptop at first, the ThinkPad X60, as I mentioned before. We later expanded to support more desktops, laptops and servers on multiple platforms, which I'll also cover later on in the talk. I should also mention that for a brief period, the Libreboot project was actually part of GNU. So we joined, I'd contacted Mike Jowitz, I don't exactly know how to pronounce the name. Anyway, I worked with Mike Jowitz in the GNU projects on making Libreboot eligible to be added to GNU. So we had the same goals as the GNU projects, free software everywhere, bringing about a world where any task that you can possibly think of could be done exclusively with free software. That's the goal, and that's our goal as well. So we were philosophically compatible, but there were some technical issues that we had to deal with. So for instance, the documentation, build system and things like that, trying to standardize it so that we used their build methods instead. That took about a year. And then finally on May 14th, 2016, we officially joined the GNU project. Unfortunately, a few months later after that, on the 15th of September, we had already had some disagreements with the GNU project over technical issues and how the project should be run. Something controversial, I should say, happened at the FSF. You can read about this on the Libreboot websites. They basically did something really nasty that we disagreed with entirely, so we just left GNU. You can actually go onto the link https libreboot.org/GNU, and you can read information about that. So we were members of the GNU project for about 4 months. It's really strange because when we left GNU, they actually resisted it. So we left GNU in September 2016, but the GNU project officially recognised that in January this year. So how is the Libreboot project funded? Well, as I said before, I run a company that sells systems with Libreboot pre-installed. We sell desktops, laptops and servers with Libreboot and Debian by default. The profits from this company are used to fund the Libreboot projects. We've funded Libreboot in several ways in the past. For instance, there's a server motherboard that we support, the KGP D16, which we had to pay for to have ported. There was also a few other boards that we paid for. Generally, we also provide infrastructure and paper development in general. So that's actually one of the main reasons Minifree exists, just to provide funding for Libreboot. At present, we have no other ways to fund the Libreboot projects. I am looking into crowdfunding in the future as a possible option if we ever try to produce our own hardware. I'm actually going to talk about OEMs at some point in the future, some point in the talk. So I'll go through some details about the components of Libreboot. So there's some confusion in the community about what Libreboot actually is. People sometimes ask me, isn't Libreboot just a deblobbed fork of Coreboot? That's not actually true. What we do in Libreboot is we basically provide something very similar to a GNU plus Linux distribution, but at the boot firmware level instead. So we have an automated build system which takes Coreboot and the various components that you need with that, utilities, payloads, and so on, and downloads, patches them. We use tested revisions of all of the software that we use, and we have build scripts which take all of the various components that you need and actually builds the firmware automatically. If you were using Coreboot directly, then you'd have to take all of these components yourself and put everything together manually. So in the same way that, let's say, Debian provides a distribution of the GNU plus Linux system with various upstreams, like, say, the Linux kernel, the GNU operating system, X11, and so on. We provide Coreboot, Grub, and various utilities that go with that. So you can think of Libreboot as a Coreboot distribution. So it's like a GNU/Linux distribution, but at the boot firmware level. So it's not for your operating system, but you can think of it that way, by way of analogy. So I'll go through some more details about exactly what components are in Libreboot. So we have Coreboot, which is the boot firmware projects that we use. I'm going to talk about Coreboot in later slides. Coreboot is the boot firmware that initializes the hardware, and it also then jumps to a payload, usually a bootloader, which then boots your operating system. Then we have payloads, so we have the Grub bootloader and depth of charge. I'll talk about these later on in the talk. We also have utilities for installing Libreboot and various other utilities that are used in the build system. Well, we also have our own tool chain. We use GCC at the moment. We are actually looking to use LLVM. I'll talk about that later on in the talk. So I'll go through some information about what Coreboot is. So Coreboot is the main projects that we use as an upstream in Libreboot for providing hardware initialization. This is what basically puts the system into a usable state so that your operating system can boot. It started in the year 1999 as a project called Linux BIOS. So around that time, in the old days, you had to have a BIOS in place which defines how the hardware works, and then your operating system used calls into the BIOS to perform various hardware functions. Around the year 1999, you had standards like PCI which came out, which meant that hardware was self-describing, so the Linux kernel no longer needed to have a BIOS in place. It could just initialize hardware and provide drivers without making any use of a BIOS. So the idea with Linux BIOS in the year 1999 was to provide firmware where you just had the hardware initialization, but without the legacy BIOS interface. Instead, their goal was to put the Linux kernel itself into the boot flash and have the Linux kernel perform all of the tasks that were previously handled by BIOS firmware. However, people started using, so Linux is a payload in Linux BIOS. So you have Linux BIOS which performs the actual initialization, and then then when you built Linux BIOS, you would have downloaded the Linux kernel separately, built that as a payload. The payload is what when Coreboot is finished initializing the hardware, it jumps to a payload, and then the payload does whatever it does. In this case, that would be the Linux kernel. So you could either use kexec to load another kernel, or you could actually make that the main system kernel if you wanted. This was inconvenient though. It wasn't very usable for a lot of people, so people started adding other payloads as well. Bootloaders. There was also a project called CBIOS, which has existed for a few years now, which actually provides a BIOS interface. So if you want legacy operating system support, for instance. This meant that the name Linux BIOS no longer really made sense. So at around 2003, 2004, Linux BIOS renamed to Coreboot. Now, Coreboot, I should explain the problems with Coreboot. Core-Boots is mostly free software, but there are some parts of Core-Boots that are proprietary software. I'll go into some details about what components these are that are non-free in Core-Boots in later slides. So it's not fully free software. We solve this in Libreboot, and I'll explain how in one of the later slides. Another problem with Core-Boots is that it's very difficult to install. It's notoriously difficult because you see reports from users all the time where they have trouble building it, then they have trouble flashing it. And then a lot of the time, for instance, you have users that make a configuration that's wrong, and they flash firmware that basically doesn't work, and they brick their system. There's usually not much user support in the Core-Boot community, and there's also not a lot of documentation for non-technical users. There's developer documentation. Core-Boot is mostly developer-oriented, but not user-oriented, much like the Linux kernel, for instance. So most people don't even attempt to install Core-Boot. That's really the main problem. That and the fact that it's only partially free software. I already explained that Libreboot is a fork of Core-Boot. So a comparison would be, if you look at a GNU Plus Linux distribution, that's a distribution for your operating system. They provide ISO images where you can install the system, and it comes with an interface that's easy to use, and they usually have community support in place for that, and plus documentation. Libreboot is the same thing, essentially, but at the boot firmware level. So we provide ROM images, which the term ROM image is a bit misleading because it's not actually ROM, it's flash, it's rewritable. But they call them ROM images anyway. When we say ROM images, we're referring to the firmware that you actually flash. So we provide that pre-compiled by default for users. This is something that Core-Boot itself doesn't do. We test everything. We provide the build system, which I explained earlier. And we try to provide documentation aimed at users. So instead of providing documentation that's designed for developers to read, we try to streamline everything as much as possible. We try to automate everything as much as possible, to the point where we can just give a user a guide where they can just follow instructions step by step and install the firmware without. And we found that this actually works. The success rate for installations in Libreboot is quite high compared to Core-Boot. More people attempt to install it because the documentation is better for non-technical people, and because we provide documentation that's designed for people who may not necessarily have as much technical knowledge, people make less mistakes. So we provide all of that and integrate everything. So we don't actually create a fork of Core-Boot. We use a particular revision of Core-Boot on different hardware, and we rebase that as time goes by. So we actually use Core-Boot as an upstream, much like, say, Debian uses the Linux kernel as an upstream. So I explained before that Core-Boot contains proprietary software. So what do we do about this? The first answer would be to fork Core-Boot and provide a dblobs version of Core-Boot. But that's not what we do in the Libreboot project. What we do is we maintain a set of scripts which searches the source code and looks for patterns inside the source code that look like proprietary software. So if you actually look in the Core-Boot source code, you will actually find, say, a C source file that does something. But you look inside the file and it will just be an array of bytes inside the file. It will be an executable. Or you might actually find binary blobs, like actual files in there. So the script searches for blobs in the source code and then reports a list of search results. Now, not all of these are blobs. You do get false positives, so we have to go through the list and decide which ones are blobs and which ones are not. And then we maintain a list of files of blobs in Core-Boot for the dblob scripts to delete. Obviously, as a result of this, we support less hardware than Core-Boot because blobs are needed on some systems in order to actually boot. So we just settle for lower hardware support. We don't want people to use proprietary software. So in some cases, we just have to say, we can't support this system. Now, I should explain, there's a new project called LibreCore. which is a fork of Core Boot, unlike Libreboot, which is a Core Boot distribution. LibreCore is not part of the Libreboot project, it's run by separate people. It started as a response to this problem in Core Boot. In recent years in Core Boot, it has been found that a lot of newer development goes into the proprietary systems from Intel and AMD. There's not really as much of a community focus anymore, according to them. A lot of Core Boot developers nowadays accept blobs much more casually than they did before. And the focus in Core Boot on Libre hardware is a lot less. So LibreCore started in December 2016 with a new focus, which is the same focus as the Libreboot project. LibreCore tries to support as much hardware as possible without any proprietary software. They've attracted a number of the developers from Core Boot as well. So they're trying to make it their own projects and to abandon Core Boot, basically. But they also share patches back and forth between Core Boot and LibreCore. We're actually looking to dump Core Boot entirely in Libreboot and use LibreCore as an upstream instead. The reasons for this is, well, because they have the same focus as us. That means that we're working with people who share our ideals. It also means that if we use their software, then if we use their version, their fork of Core Boot, LibreCore, we may not necessarily have to do as much work on the deblob scripts. We can abandon the whole concept of having deblob scripts. Because what LibreCore does is it provides deblobbing for Core Boot, but inside the tree itself. So they fork Core Boot and they remove all of the blobs. There is one exception. I have found that they do distribute microcode updates, but I'm not sure about anything else. I will say though, in Core Boot, in recent years, there has been a push to moving all of the binary blobs in Core Boot to a separate repository. But there are still some blobs left in Core Boot. So you can go onto the website librecore.info for information about that. This is a very new project, so it's not very established at the moment, but we're looking to use that instead of Core Boot. I'm going to go through some examples about exactly what kinds of binary blobs are used in Core Boot. Well, the first one is the entire boot firmware. On most new systems from Intel and AMD, the entire hardware initialization is actually a binary blob provided by the manufacturer, Intel or AMD in this case. What Core Boot then does is they provide code around that just provides an interface for it to use. We call this shim boot because it's not Core Boot. The hardware initialization on modern Intel and AMD systems in Core Boot is entirely binary blobs. So AMD used to provide source code for this between the years 2011 to 2014, but then they stopped. Obviously, this has all of the same problems as non-free boot firmware, because it is non-free. If you look at a standard proprietary BIOS firmware, or UEFI, on modern systems, shim boot, as we call it, is more or less the same. It has all of the same freedom issues, the same security issues, everything. We don't consider this Core Boot in Libreboot projects. Another example of a binary blob typically found on most systems is called the video BIOS. So when you start your system, before your operating system boots in the early boot process, the video BIOS provides initialization so that you can have a display. It also provides some functions for the drivers to use in your operating system for whichever video hardware you have. We have free initialization. Now, Core Boot doesn't provide this itself because there are so many different graphics cards out there. When you use a system, it's common for people to use all different kinds of chipsets. Even if it's a laptop, you find different companies that provide different chipsets in their laptops. For instance, they might provide an NVIDIA chipset instead of Intel. So what Core Boot does is they don't provide the video BIOS themselves. You get that from the manufacturer and you put that in your Core Boot image. We use free video initialization in Libreboot. In Core Boot, this is referred to as native graphics initialization. Some graphics chipsets don't actually need a video BIOS or any initialization firmware. So, for instance, on some NVIDIA chipsets and some older Intel chipsets as well, you can use the video hardware without having any initialization firmware for it. The Linux kernel can initialize it on its own. But that's a rare exception. Another major blob that's found on a lot of Intel systems nowadays, well, all Intel systems actually, from the year 2007 and beyond, is called the Intel Management Engine. This is a separate computing platform, it's a separate system inside the system. It's embedded inside the North Bridge on older systems and in the platform control hub on newer systems. It has its own access to memory, to the main system memory, through what's called the DMA engine. It has its own networking. It provides various extensions. One of the main extensions that the management engine provides is called AMT, or Active Management Technology. This provides remote access features for you to make configuration changes, independently of whether an operating system is even running. It's typically done through a web interface. AMT is typically used in corporate environments. The thing is, though, that's actually verified to be insecure. We had a theory that this could potentially be a backdoor, and it's true. So on some Intel systems, for instance, the web interface that AMT uses was found to have bugs in its TLS engine, in its TLS implementation. So you could snoop traffic over the network, for instance. Anyone who has control over your system via AMT has absolute control over your system. If it has DMA, that also means, for instance, that it could leak encryption keys that are stored in memory. The management engine is cryptographically signed as well. When you boot the system checks for the signature on that. If you make modifications to the management engine or remove it, your system won't boot. There are various extensions on top of the Intel Management Engine besides just AMT. One of them is called Intel Boot Guards, which on modern Intel systems prevents other boot firmware from being used. So if you wanted to install Core Boots or Libreboot onto a system that has the Intel Boot Guards, you wouldn't be able to do it. The system would check the signature of the boot firmware that you're using and reject it. You can find more information about this on the libreboot.org/FAQ. That's our FAQ section. There is an exception nowadays. This is also mentioned on the Libreboot FAQ. There was some research a while ago into so on modern Intel systems you can't remove the management engine and you can't modify any of it. But there was a workaround that people in the corporate projects found for removing the networking features in the management engine. Removing all of the malicious features to the point where it's basically useless and doesn't do anything. We're considering whether to add some of these systems in Libreboot. We're not currently working on that. We're looking for input on that from the community. You can go onto the Libreboot FAQ section and read the information about the management engine on there, and there's a link to this. There's also a use. Yeah, go on to the Libreboot FAQ, and we've got some information about this. This is something new that we're looking into, so we're not really doing anything with this yet. Also, we don't know if that makes the system secure. We don't know if it actually removes malicious features or if there's still some features left that you don't want. So I should also mention that AMD is just as bad as Intel. So AMD has their own equivalent of the Intel Management Engine called the Platform Security Processor. They also provide the hardware initialization as blobs, just like Intel. They have all of the same security and freedom issues as Intel. You can go onto the Libreboot FAQ section and read about, this is actually a typo, it's meant to say AMD, not Intel. Yeah, if you go onto the Libreboot FAQ section, we have information about the various problems with Intel and AMD. We recommend that people don't use modern Intel or AMD hardware because of the freedom issues that they have. There is an alternative. So IBM recently freed their power platforms. So this used to be called PowerPC. Modern power CPUs have been freed. So if you buy a system from IBM nowadays, you can actually port. Not all actual systems that you can buy come with pre-boot firmware, but it's possible nowadays to have actual OEMs pre-installing Libreboots. There was a project called the Talos Workstation, which I'll cover on the next slides, which attempted to provide Libreboots at the OEM level. They wanted to manufacture their own hardware, but using the IBM Power platform instead of x86. This hardware is available today to actually port Libreboots, and you can buy these systems from IBM and actually sell them. And IBM actually supports this. So this is something that we're looking into. There was a project called the Talos Workstation, which attempted to provide this as an OEM. It was a crowdfunding campaign that they were running. Unfortunately, that crowdfunding campaign failed. The problems that we found, well, the problems that they found, rather, the hardware is very expensive to sell. It's not actually possible at the moment to compete with the likes of Intel or AMD in terms of price, even though the hardware itself is equivalent performance-wise. So that's one of the main reasons that the campaign failed. We're looking to restart attempts at providing power hardware to the community, because this is one of the architectures that we can use in the future. Intel and AMD is currently a dead end in terms of free software. We can't use Intel or AMD. This is currently the only alternative to x86 when speaking about open power. So the crowdfunding campaign, there are some open power systems that you can get now, but they're usually very expensive and they're usually only available as servers. So there currently are not that many alternatives that you can use, at least for modern hardware, if you want free boot firmware. If you want to do software development, for instance, ARM hardware is often low end. It's often not powerful enough for real software development in a lot of use cases. There is a server platform which Libreboot supports, which I mentioned earlier, the Asus KGP D16, which is still relatively modern and still high-end enough for most people to actually use for either development purposes. It can also be used for hosting and any other kind of server application that you need. You can find more information about that on the website. We actually sell that at Minifree as well. But at the moment, there are no solutions in OEMs. If you go to an OEM, they all provide non-free boot firmware. That was one of the things that the Talos project was trying to solve. The crowdfunding campaign failed, so we're currently stuck. I mentioned before, so moving on to another topic. I mentioned before about payloads. So Core Boot provides hardware initialization only, and then jumps to a payload. The payload is included externally, and typically by another project, not run by the Core Boot projects. On x86, we use the Grub bootloader for booting your operating system. On Chromebooks, we use the depth charge bootloader. There are some Chromebooks supported in Libreboot, which I'll explain later on in the talk. They don't use Intel processors. There are also many different payloads that you can use in Core Boot. So bootloaders, low-level applications like games. There are some games implemented as Core Boot payloads. The most common use case with payloads in Core Boot is to use a bootloader or some kind of BIOS implementation. So why do we use the Grub bootloader instead of, say, CBIOS, for instance? CBIOS would provide legacy support for any operating system that you want to use. There are advantages to using a bootloader in Libreboot. In particular, so with the Grub bootloader, for instance, you get much faster boot speeds because you're skipping So when you're using a typical system, you go through the hardware initialization, and then you go through either BIOS or UEFI firmware, and then you go to a bootloader, which boots your operating system. In Libreboot, you jump straight to the bootloader, and you can configure that to however you want. Grub has support for decrypting partitions as well, if you're using Lux encryption. So, for instance, you can encrypt the /boot directory. You can't do this on standard firmware. It also has the option to check GPG signatures, which, again, most firmware can't do. A use case for this would be the Linux kernel, for instance. You could sign it and then check the signature on boot. You can also boot the kernel, a Linux kernel, directly from the flash chip. So Coreboot has its own file system in the boot flash called CBFS. You can put a Linux kernel there and configure Grub to boot that. So instead of having it on the hard drive, you'd have it in the flash. It's also useful for testing because Grub is capable of booting any other Coreboot payloads. Now, because we use the Grub bootloader, some people ask, well, if I want to reinstall my operating system, would I have to also reflash with a different Grub configuration? And the answer is no. The Grub configuration that we use in Libreboot by default will load a Grub configuration file from the hard drive or from your SSD if present. And you can also change the configuration that's in there if you want. So that's on x86. On Chromebooks, though, that use... So we support several Chromebooks in Libreboot that have Rockchip CPUs in them. Rockchip is a company that produces ARM embedded hardware. So depth charge is the default payload that's used on all Chromebooks. We use this in Libreboot as well. It provides several security features that are similar to Grub. So for instance, with depth charge, you can sign your kernel and check the signature on boot and verify that the boot firmware has not been corrupted some way. So I'll start talking about operating system support in Libreboot. Because of the configuration type that we use in Libreboot, not all operating systems are supported. The GNU Plus Linux system is fully supported. Most distributions are compatible. You can also use full disk encryption, including /boot, unlike on most other systems. If you go onto the documentation section in Libreboot, libreboot.org/docs/GNU Linux, there are instructions there for how to install the system. We also support BSD. This wasn't the case a while ago. We recently added support for several of the BSD systems, though. NetBSD works, OpenBSD works. There's also a project called LibertyBSD, which is based on OpenBSD. That should also work. FreeBSD, we had some problems with video corruption on boot, but that also boots. You could use that in text mode if you wanted to. We have a section for that on the Libreboot website. If you go to libreboot.org/docs/BSD, you can find instructions there for how to install BSD as well. Other operating systems? Well, there are other free operating systems besides just GNU Plus Linux and BSD. We don't know if these are compatible. They're probably not, but we're not sure. So this would have to be tested. So part of the reason why I'm here is to talk about where the project is going and what we're currently doing to improve Libreboot. The last release of Libreboot was in September 2016, so the current release is about 4 months old now. So we've already added several new Chromebooks to Libreboot, which use ARM processors instead of Intel. We've recently merged a new build system, but that only currently builds the Chromebooks that we support. The Intel and AMD systems that we support are currently still built using the old build system that we had before. The new build system has several advantages. So one of the main advantages that it currently has, for instance, is if you provide a Linux kernel config, it has support for building a Linux kernel by default. On ARM Chromebooks, you have to build your own custom kernel configuration. You can't use upstream. You have to use on most Chromebooks you use a special branch of the Linux kernel that's maintained by Google, and you very often have to build from source, especially if you're using one of the less well-known distributions. So the new build system in Libreboot has support for building a Linux kernel payloads by default. This is currently targeted at Chrome OS devices, Chromebooks in other words, but we will be extending this. We could extend this in the future for Petite Boots, which is another bootloader that we would like to support as a payload option in Libreboot. We want to add support for using alternative compilers as well. We currently only use GCC. There are several features in Libreboot that we already support, but in terms of actual features, we're mostly working on hardware support at the moment in Libreboot. So there are some newer systems that we're looking into as well. How to help? So if you want to get involved with the Libreboot project, there are several ways that the community currently falls short. So as I mentioned before, there's currently a lack of hardware manufacturers, or OEMs, that provide Libreboot pre-installed. This is something that we want to fix. So if anyone has the skills and the resources to be able to do that, then that's something that we would like. We also want people to continue working on porting newer hardware to Libreboot as well. You can tell people about Libreboot and promote it to people, explain why it's important. You can help people to install Libreboot as well if they have issues. You can help us improve the documentation. There are many issues with the current documentation that we have. There are always ways that we can improve. So if you have, you can also submit bug reports, for instance. So especially during a release cycle, like if we're testing a new release, you can submit bug reports. So if you go to libreboot.org/tasks, you can submit any issues that you find, you can submit bug reports, and patches are submitted using the instructions at libreboot.org/git. You can contact the Libreboot projects in several ways. So we have an IRC channel on Freenodes, #Libreboot. We have a subreddit now as well. That's fairly recent. We also have a list of developers who you can contact directly in the Libreboot projects. I'm listed there. There are several other people as well on libreboot.org/contrib. We currently don't have a mailing list, but we're looking to create one in the future. Thank you. Are there any questions?
Yes, hello Leah. Thank you very much for your project. I'm using Libreboot for some months. Here.
Where are you? Oh,
yeah,
sorry.
Excuse me. I should have made the sign. So my question is, do I have to fear legal issues if I apply Libreboot on my BIOS chip? I mean, will I receive a letter from an advocate from Intel or the mainboard manufacturer? Do you have any experience or things to tell about that?
So I think the question was, are there any potential legal issues with using Libreboot in, say, an organization? Not that I'm aware of. If you're in the US, you may have problems with DMCA or something like that. But in Europe, I don't think this would be a problem. I've never heard of problems. There are institutions that use Libreboot, and they haven't had problems. If there are potential issues, it's just something that we'd have to come across as a community in the future. But at present, I'm unaware of any issues.
Yeah, thank you. Maybe would you think that this is related because as far as I know, Libreboot often is usable for kind of older hardware. Maybe this is the reason why there is not any trouble to be expected?
I don't understand the question. Could you rephrase?
Maybe you can discuss this later, because here are some more people having questions.
Are there any more questions? I'll talk to you outside if you want to ask, because this sounds like a very in-depth discussion. It's not something that can really be answered in half a minute. Any more questions?
Yeah, so I was actually curious what does it take to, I'm here, to work on developing cardboard, because, well, I imagine you don't exactly flash an actual hardware for every build you make when you, as a developer, but not only because that would fry the chip, the flash chip pretty quickly. So do you have do you run it on a VM, or what does it actually take?
So I think the question was, what kind of mechanism do we have for testing hardware? What do we use for that? Do we have some kind of automated system in place?
No, actually, I mean just for developing, because like when you program and then build the image, you don't actually run every iteration on the actual hardware, do you?
No, we typically test before there's a new release. We don't typically test every image that's built, because otherwise testing would take too much time. So we typically just make sure that the software builds, and we test the firmware, but we test it usually in the run-up to a release, and then fix any issues that are found. As for virtual machines, we don't typically use virtual machines in Libreboot. We have to test on real hardware. I can't hear you. You don't have the mic.
Yeah, maybe this is. It's like one question per user. So please try to be short and specific, and otherwise you have to resort later. Your question?
Hi. I applaud your stance on removing blobs, especially from the low-level firmware on these boards. But I'm an electronic engineer, and I design ASICs basically quite regularly. And any hardware that doesn't have any certain modern chip that doesn't have a blob interface to load microcode will generally have a mask ROM inside in a metallization layer that you can never change. And given that, I would rather have external blobs of microcode rather than a metallization layer with possible bugs in that I will have to throw the entire hardware away. Now, what I'm also saying is there a project in Libreboot to reverse engineer those blobs and replace them with open microcode?
Where are you? So the question was, I think, about microcode blobs. You were arguing the case for, so you said that there's already microcode built into the CPU, and the updates, although technically binary blobs, are not provided in Libreboot. So were you asking about our opinion on including updates? I'm not sure.
Yeah, basically what I was saying was that I applaud the very purist view of not having them, but the idea of reversing the updates.
Yeah, this is actually up for debate in the Libreboot projects, because the microcode for the CPU is already comes built in, and then manufacturers typically provide volatile updates at boots, which you have to apply at every boot. So if you provide microcode updates, if you exclude microcode updates, you're still using microcode that's built into the CPU. You're just using microcode that's older, and it just happens to be inside a mask ROM, so it's not updatable. So yeah, so if you're using the microcode that's built into the CPU, you could have potential issues in terms of security and so on. Intel and AMD also maintains a list of bugs for every CPU generation that they have. You can search for the errata for each CPU model and find out exactly which different microcode update revisions fix which bug. Yeah, this is currently up for debate in the Libreboot projects. Our policy is to currently exclude microcode updates, but there are a sizable number in the community of people in the community that would argue the case for having microcode updates included, because even if you exclude them, you're still running the same microcode, just an older revision anyway. So I don't know how to answer your question at the moment. This is not something that I should answer myself unilaterally. This is something that we should have as a debate within the community. Any more questions?
So one last question.
Thank you for the talk.
You're welcome.
Have you ever contacted blob developers, and if so, have you ever succeeded in getting technical information in order to rewrite it in a, understandable manner, and, to remove it, re-implement it?
No. So the question was, do we have contacts with manufacturers to potentially have specifications released so that we could potentially work on reverse engineering and implementing Libre firmware? Is that the question? We've had some talks. We've attempted this in the past, but they usually don't work with smaller projects like ours. Most of the hardware manufacturers, including the big ones like Intel and AMD, are mostly uncooperative. So we haven't had any success with that. The work that we do in the Libreboot projects at the moment is mostly based on reverse engineering. I will say, though, there are some individuals from these organizations that do provide source codes. Intel and AMD have also cooperated with Coreboots in the past, but it's generally not full cooperation. Most of the work is based on reverse engineering. Any more?
So time's up. Thank you for being here.
If anyone wants to ask me more questions, you can meet me up outside in the corridors. That's fine.
Yeah, and thank you, Leo, for presenting the project. Thank you.
I mustn't forget my laptop. I want to take this with me. Oh, yeah.